Okay. Oh, host. Just okay. Should I directly join?
Just directly join.
Oh.
Then I'll make.
Family and see my
Change. A bit.
should I directly add the append the number here?
Give me 1 second. Let me get started. Then you might just use my computer. Until I hand it over. Good afternoon, everyone. How are we doing today? We are excited that all you guys are able to stop by for this presentation on just getting us ready, getting us started to use AI, artificial intelligence, kind of understand the basic concepts behind it, and hopefully get us to a point where we can start using it for our research and maybe even using it in our classrooms. I have Dr. Alo here who wants to say a few words, so I will let him do that.
Thank you. Yeah. I just gotta move it now. Okay. I get in here. Okay. Wow, this is low. You're tall. Let me try this. Let me try this. Okay. Hello, everybody. Let me see. Okay. So, oh, there's feedback. Hold on just a moment. Okay. Still feedback. Yeah.
Go ahead.
You probably just put it on mute, Tom. Yeah. Hmm. Okay. Can you hear me okay, everyone? So welcome. I'm very, very glad to see and very pleased to see how many are participating in this particular workshop. I think this is the second or the third in the series. Is that right?
Yeah.
So anyway, I just wanted to say a few words, what the setting here, and we're very, very pleased to see such a wonderful, wonderful turnout. And I hope that you stick with the sessions and complete it, and we'll have some kind of survey at the end to get your feedback, because all of this is, we want it to be to serve you, right? And your needs, okay? So let me back up just a little bit. So this is funded by a major grant that it was made from the Department of Commerce. It's called Connecting Minority Communities, okay? It's a $5.35 million grant. And it's part of what the Biden-Harris administration was trying to do to get connectivity, accessibility out to everybody, okay? What does that mean for FAMU? For FAMU, that means right now we are being sure that every place on campus has connectivity. Okay, number one. Number two, we are also connecting the adjacent communities to the campus. You know, if you remember during the pandemic, we had students go home and they had no Wi-Fi connections, no accessibility. We gave laptops, we did all kinds of hotspots, we did whatever we could. So now we're going to we are hooking those people up. And that's what Robert Seniors, our Chief Information Officer and VP, is doing. Okay. My part of the grant is called Building Big Data University, K through 20. And this is part of that piece of Big Data University K through 20. We're doing something with the Developmental Research School to infuse data science and artificial intelligence in the curriculum. But let's come up here to what you all are doing. So right now, the workforce has changed and is changing. As you know, it's highly digitalized, highly digitalized. The workforce expects our graduates not only to have their degrees in civil engineering and humanities and journalism, whatever it is. Those are wonderful degrees that we produce, but they also want to see the graduates know how to deal with these tools, artificial intelligence, machine learning, how to handle big data. What we call this is the cyber infrastructure professional, okay? That goes into industry, goes to the workforce, or goes to graduate school and gets into the world of data, big data, gets into the world of using artificial intelligence and machine learning. We're just breaking the ground on this because it's not just about artificial intelligence. Down the pike, we have additional advanced technologies that will be coming forward. Okay. So right now, it's just so important that we have this faculty development. And we will be doing more of this, we will have more cohorts. But in this particular cohort, you will have people from our what I call our data science, artificial intelligence, machine learning, research and learning cluster. Dr. Jinwei Liu today will be presenting. Dr. Erdal Maurice works as part of this cluster. And we have several other data scientists, including myself, who leads the cluster, who will be doing these workshops. And so we do want to hear back from you. We want to know, we want to hear how this is helping you. And so there are what, 3 sessions, 4 sessions? Is it
3
4?
right now.
3, okay. 3 sessions that we hope you will maintain your attendance. And if we need to do more sessions, we will do it once we hear back from you, okay? So thank you for coming. We appreciate seeing you, and this is so exciting. We have to join the rest of the universities across the United States and be in this whole field where AI and machine learning, deep learning are integrated into the curriculum. By the way, before I drop off, I will say there are examples already of grants that our group has obtained, where the one grant that I will tell you about is integrating artificial intelligence and machine learning in biology. And so the biology department is doing that. Clement Yeju is the PI on that. But we're looking to see more of you, and we will be glad to help you all if you are interested in doing a similar type of proposal for your discipline. Okay? So thank you very much. We appreciate seeing you, and we're looking forward to continuing our collaboration. Thank you. Go ahead, Erdal.
Let me try. Hold on. Okay. Can everybody hear us clearly? Can everybody online? Can we hear it clearly? We're trying to make sure that everyone can hear before we get started.
Yes.
Yes.
Okay. So okay, yeah. Try turning up your volume if you're having any issues with the sound. So a quick overview. What we're trying to have right now are 3 sessions. The first session is just an introduction to some of the fundamental concepts for artificial intelligence. The second one is us running through a notebook, basically us showing you the physical process of, hey, this is how you actually get this done. And then hopefully the third one would be more of a domain-specific area. So in that way right here, you can bring your data, you can kind of discuss and try and figure out how exactly can we get your data or your information or your questions into this where you can then use artificial intelligence to help answer your questions, right? Sometimes you may think, for example, that you don't have enough data, or in your area or in your science, you may not have enough data, but there actually are ways around those kind of issues. I know a lot of us, for example, we have lots of texts and have words, interviews, and back and forth with people. There are actually all ways to use that information to go ahead and still pull together an AI solution for you. All right. With that, I will give it over to Dr. Liu. I need to make him the host. What you got?
No, Dr. Liu, we cannot hear you.
Okay, can you hear me now?
Yes.
Okay. Thank you. Good afternoon, everyone. My name is Jingwei Liu from the Department of Computer and Information Sciences at FAMU. Today, I'd like to give you a high-level introduction to data science, artificial intelligence, and machine learning. Okay.
I'm not hearing anything.
Give us a second, folks. His computer died. It's really sad, really is. Like you're saying, while he's waiting, we'll give you a survey at the end. Of the you want to just use my computer?
It's fine.
It's fine. Okay. Yeah. We'll give you a survey at the end. Also, what am I going to say right here while we're waiting? I don't know. Oh yes, go ahed. Question. Yes.
The hearing you talk about it, I'm interested in using it. And I think you said earlier that you might redo it, or would there be a possibility of reaching out to you one-on-one so we could possibly work this data?
Yeah. So the answer to all those questions are yes. So one, we will try to provide recordings of the meetings. Two, if we will create more meetings and more meeting times if there is one that you missed what you really want to attend to. And three, yes, we can schedule one-on-ones for us to have some kind of consultations to help you work through any issues, questions that you may have. That's yes, yes, and a yes. Yes. Yes, we'll have yes, we're recording all the meetings. And yeah, part of the question we will ask later on is for your email address in the survey, and then we will use that email address to send you out information, not from just this meeting, but from all the meetings. All right, any other questions out there while we're waiting? He's almost there,
Yeah.
folks.
Yes, will we need to have any software to do the training?
No, so because it'll be starting out high level, you won't need any software, but we can get you access to software using the NRP if you need to do you know, the main thing about artificial intelligence, the thing is you need a lot of computing power sometimes. We can get you computing power through the NRP for free. So it's the National Research Platform. It's about, I think, 35 schools. They all have supercomputers and GPUs, and they're all connected together across the country through what's called a National Research Platform. And we just need to give you a namespace on there, and then you have access. You can literally, they're showing on the last meeting that there's this computer they're taking the weather data from basically ever since pictures of the Earth every hour on the hour, all the weather data, and they were taking all of that and they were training a neural network using that. And that thing was just using up a whole bunch of power. But it's a link. You just log on. And so from your computer, you can do it from your laptop or from your iPad. You can just log on. It'll do all the hard work for you. If the servers are here on campus or the servers are in California, yes, it'll do that data analyst for you. Yeah. That's the thing about it is there's literally they want more people on there because they have so much extra capacity right now that's just not being used, and so they want us to get more people on there. Yes, this is 1 of 3. Yes, AI machine learning. How are we doing?
Now it works.
You ready?
Yes.
You log back on? Are you?
Yes. Join the meeting. I can share my screen.
All right, then go ahead.
So let me share my screen.
You muted it. You muted. All right, they can hear you, so just go ahead.
Okay.
All right, we're back, folks.
Okay. Sorry for the inconvenience. Okay, let's continue.
You're just waiting for
Okay. So it's already recorded, right?
Yeah,
Okay.
perfect.
Good afternoon, everyone. Today I'd like to give a high-level introduction to data science, artificial intelligence, and machine learning. As we know, a lot of data is being collected and warehoused. The data can be web data, e-commerce data, financial transactions, bank transactions, credit transactions, online trading and purchasing data, and social network data, such as the Facebook data, Twitter data. Okay, so there are different types of data, such as the relational data, text data, semi-structured data, graph data, social network data, semantic web data, and streaming data. So for relational data, I believe everybody is familiar with it. So, we use the relational database such as MySQL, PostgreSQL to store the data. The data are stored in the tables in a database. So those are the relational data. And for text data, we collect the data from the website. So those are the text data. And for semi-structured data such as XML, and for semantic web, semantic web is an extension to the World Wide Web. The purpose of the semantic web is to provide structure to the web and data in general. And streaming data is a continuous flow of data from multiple sources that is processed in real life. Okay. Oh, sorry, let me go back. Okay, so what to do with this data? Here are some applications like aggregation and statisticals, indexing, searching, and querying, knowledge discovery. So for aggregation and statisticals, we can use some technology or technicals such as data warehousing and online analytical processing, that is OLAP. OLAP is a technology that helps business analyze large amounts of data to support decision making. For searching, there are different search methods like keyword-based search, and also we can use data mining technology and statistical modeling for knowledge discovery. For example, we can collect the data from the social networks like Twitter or some community question and answering systems such as Yahoo Answers. Then we can use apply data mining technology to the data set. And then we can identify some or get some insights. Okay. Okay. What is data science? Data science is an area that manages, manipulates, extracts, and interprets knowledge from tremendous amount of data. Data science is actually a multidisciplinary field of study with a goal to address the challenges in big data. Data science principles apply to all data, including big data and small data. This diagram shows us the relationships among artificial intelligence, machine learning, and data science. From this diagram, we can see that data science overlaps with artificial intelligence and machine learning. Data science provides a foundation for AI success because data scientists propel and clean data sets to make them suitable for AI algorithms. So in this diagram, we can see that there are some algorithms such as support working machine, KNN, decision trees, deep learning. So those algorithms belong to both machine learning and artificial intelligence, and also they belong to data science. So data science overlaps with AI and machine learning. Okay. Serious and technicals from many fields and disciplines are used to investigate and analyze a large amount of data to help decision makers. In many industries, such as science, engineering, economics, politicals, finance, and education, For example, theories or technicals from computer science, such as pattern recognition, visualization, data warehousing, high performance computing, databases, and AI. So those technicals can be used to investigate and analyze a large amount of data. And similarly, the theories or technicals from mathematicals, such as mathematical modeling, and the theories or technicals from statisticals, like statistical and stochastic modeling, probability, they can be used to investigate and analyze a large amount of data to help decision makers. Okay. Why data science? Here are some motivations or reasons. First, new technology makes it possible to capture vast amounts of data, such as login data or sensor data. The sensors are widely used in many applications. Sensors are usually deployed in an area to collect the data from the environment, like the water pollution data, humidity, etc. So the sensors collect a large amount of data. And also the log files in our computers or servers, they there are a lot of data stored on the servers. And the second, computing advances makes it possible to analyze data on ever-increasing scales. Third, the prominent role models such as Google, Manifold, have proven the power of modern data analytics. Here are some career opportunities. These are the statisticals based on U.S. Bureau of Naval Statistics, a World Economic Forum. Okay, so first, the rise of data science needs will create roughly 11.5 million job openings by 2026, based on U.S. Bureau of Naval Statistics. By 2026, data scientists and analysis will become the #1 emerging role in the world, based on World Economic Forum. Data science and artificial intelligence are amongst the hottest fields of the 21st century that will impact all segments of the daily life by 2025, from transport and logistics to healthcare and customer service. Also, data science helps brands understand their customers in a much enhanced and empowered manner. Data science allows brands to communicate their story in such an engaging and powerful manner. Big data is a new field that is constantly growing and evolving. The findings of data science and the results can be applied to almost any sector, like travel, healthcare, and education, among others. Data science is accessible to almost all sectors. Okay. Okay, now I'd like to introduce some applications of data science. This slide shows us some applications of data science, such as internet search, digital advertisements. Many search engines, such as Google, Yahoo, Bing, and Ask, make use of data science algorithms to deliver the best result for our search query in a fraction of seconds. Considering the fact that Google processes more than 20 petabytes of data every day, digital ads have been able to get a lot of higher call-through rate than traditional advertisements. They can be targeted based on a user's past behavior. And here are some more applications of data science, such as recommender system, image processing. Many companies, such as Amazon, and Google use recommender system to improve the user experience. The recommendations are made based on previous search results for a user. So, Amazon uses recommender systems, and also Google, like YouTube, we can see the recommender systems on YouTube. Okay, YouTube can recommend the movies to users based on the users' past experience. Okay. Here are some more applications of data science, such as speech recognition, price comparison websites. Some of the best examples of speech recognition products are Google Voice, etc. Using the speech recognition feature, even if you are not in a position to type a message, your life wouldn't stop. Simply speak out the message and it will be converted to the text. Okay. Here are some more applications of data science, such as airline routing planning, fraud, and risk detection. Airline industry across the world is known to bear heavy losses. Now, using data science, the airline companies can predict flight delay, can decide which class of airplanes to buy, and also whether to directly land at a destination or take a halt in between, and also efficiently effectively drive customer loyalty programs. The earliest applications of data science were in finance. Over the years, banking companies learned to divide and conquer data via customer profiling, past expenditures, and other essential variables to analyze the probabilities of risk and default. Moreover, it can also help them to push their banking products based on customers' purchase experience. So this is about the applications of data science for airline routing planning and also fraud and risk detection. Here are some more applications of data science, such as healthcare and Internet of Things. Procedures such as detecting tumors, employee various measures such as and also frameworks like MapReduce to find optimal patterns for tasks like long textual classification. It applies machine learning methods such as support working machine, content-based medical imaging indexing, and wavelet analysis for solid textual classification. So this is the application of data science in healthcare. Here are some real-life examples. Companies can learn your secrets, shopping patterns, and preferences. For example, can we know if a woman is pregnant, even if she doesn't want us to know? So probably we can know whether a woman is pregnant based on the woman's shopping patterns and preference. Okay, and also data science was used in election. 1 million people installed the Obama Facebook app, and that gave access to info on friends. Okay. This slide shows different types of data science, such as regression, clustering, association analysis, anomaly detection, recommendation engines, deep learning, time series forecasting, text mining, feature selection, and classification. Okay. Okay. Now I'd like to give you more details about these different types of data science. For classification, it aims to predict if a data point belongs to one of the predefined classes. The prediction will be based on learning from the known data set. So there are different classification methods, such as binary classification. For binary classification, there are two classes, such as the positive class or the negative class. And also there are multiple class classifications. In that case, there are multiple classes. Okay. So for binary, compared to multi-class classification, normally binary classification is relatively easier. Here are some algorithms for classification, such as decision trees, neural networks, Bayes models, induction rules, k-nearest labels, that is KNN. Another type of data science is regression. Regression aims to predict the numerical target label of a data point. The prediction will be based on learning from known data set. For regression, there are some algorithms such as linear regression and logistical regression. Another type of data science is anomaly detection. Anomaly detection aims to predict if a data point is an outlier compared to other data points in the data set. So for anomaly detection, there are some algorithms such as distance-based, density-based, and also LOF. Distance-based and density-based methods are both used to identify outliers in data. And the LOF is density-based algorithm that uses these concepts. LOF stands for local outlier factor. Okay. Another type of data science is time series. Time series aims to predict if the value of the target variable for future time frame based on the history values. For time series, there are some algorithms such as exponential smoothing or Riemann regression. Another type of data science is clustering. Clustering aims to identify natural clusters within the data set based on inherent properties within the data set. There are some algorithms for clustering, such as k-means, density-based clustering. Association analysis aims to identify relationships within an item set based on transaction data. So for association analysis, here are some algorithms such as LP groups, a priori. Okay. How does data science work? This slide shows us the process. So the first step is to collect the data. Basically, the data is the raw data. In this step, the raw data is gathered from various sources that explain the business problem. The second step is to analyze data. By using various statistical analysis and machine learning approaches, data modeling is performed to get the optimal solutions that best explain the business problem. The third step is to gain insights. Actionable insights that will serve as a solution for the business problems are gathered through data science. Okay. Here is an example. Suppose there is an organization that is working towards finding out potential needs for their sales team. They can follow the following approach to get an optimal solution using data science. First, they can collect the data, that is gathering the previous data on the sales that were closed. Second, they can use statistical analysis to find out the patterns that were followed by the leads that were closed. Finally, they can use machine learning to get actionable insights for finding out potential needs. So these are the 3 steps. Now I'd like to introduce data mining process. Data mining is a process of discovering various models, summaries, and derived values from a given collection of data. There are 6 essential steps to data mining process. They are business understanding, data preparation, modeling, evaluation, and deployment. So in business understanding step, we clearly define the problem, what our goal we want to address with data mining, and identify relevant business questions. In the second step, that is the data understanding step, we collect and explore the data to gain a better understanding of its structure, quality, and content in data. In data preparation step, we prepare the data for analysis. This includes data cleaning, data integration, data transformation. In the modeling step, we build a predictive model by using machine learning algorithms. This includes selecting an appropriate algorithm, training the model on the data, and evaluating its performance. In the evaluation step, we evaluate the performance of the model using various evaluation metrics like accuracy, precision, recall, F1, and so on. In the deployment step, we deploy the model into the production environment. Okay. Data scientist is the sexiest job of the 21st century. They data scientists find stories, extract knowledge. They are not reporters. Okay. Data scientists are likely to realizing the opportunities presented by big data. They bring structure to it, find compelling patterns in it, and advise executives on the implications for products, processes, and decisions. There are different types of data scientists. This slide summarizes the different types of data scientists, such as machine learning scientist, statistician, software programming analyst, data engineer, actuarial scientist, business analytical practitioner, quantity analysis, spatial data scientist, mathematician, digital analytical consultant. Okay. What do data scientists do? In academia, data scientist is basically trained in some discipline, works with large amounts of data, grapples with computational problems posed by the structure, size, messiness, and the complexity and the nature of data, and solve real-world problems. In industry, a data scientist knows how to extract meaning from the and interpret data, which requires both tools and methods from statistical and machine learning, as well as being human. And also they spend a lot of effort in collecting, cleaning, and many data utilizing statistical and software engineering skills. And also they perform exploratory data analysis, find patterns, build models and algorithms. And also they communicate with their findings in clear language and with data visualizations so that even if their colleagues are familiar with the data can understand the implications. Okay. Now I'd like to move on artificial intelligence. Artificial intelligence is a study of how to create intelligent machines that can simulate human thinking capabilities and behavior. What does AI really do? Here are some use cases or applications such as knowledge representation, automated reasoning, planning, machine learning, natural language understanding, machine vision, speech recognition, finding data on the web, robotics, and much more. Okay. Here is a short history of AI. In 1943, my colleague and Peace discussed the Boolean circuit model of brain. In 1915, Alan Turing publishes Computing Machinery and Intelligence. In 1950s, early AI programs, including Samuel Checker's program, etc., were developed. In 1956, artificial intelligence was adopted in Dartmouth meeting. In 1965, Robinson's complete algorithm for logical reasoning was proposed. Between 1970 and 1990, the knowledge-based approaches were developed. Then statistical approaches were developed. Okay. This slide shows us the AI levels. There are different AI levels, such as artificial narrow intelligence. Artificial narrow intelligence, also known as weak VI, is a type of artificial intelligence that is designed to perform a single task or a narrow set of tasks. Another level of AI is artificial general intelligence. Artificial general intelligence refers to the hypothetical intelligence of a machine that possesses the ability to understand or learn any intellectual task that a human being can. Another AI level is artificial superintelligence. Artificial superintelligence is a hypothetical software-based AI system with intellect based on human intelligence. So there are different types of AI. There are different types of artificial intelligence, like deep learning, machine learning. Now let's see. This slide shows us machine learning. Machine learning is a type of AI that enables machines to learn from data and deliver predictive models. The machine learning is not dependent on any explicit programming, but the data fed into it. It is a complicated process. Based on the data you feed into machine learning algorithm, the training given to it and the output is delivered. A predictive algorithm will create a predictive model. This diagram shows us the relationship between AI and ML. As we know, machine learning is a type of AI. Okay. Now let's see. There are different types of machine learning, such as supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is much like a classroom environment. Well, okay, let me, due to the time limit, let me speed up the presentation. Okay, supervised learning is much like a classroom environment while a knowledgeable teacher guides the learning process. An example of unsupervised learning can be dump a bunch of shapes of color of the floor and asking a child to categorize them. And for reinforcement learning, training a dog using targets as insensitive is commonly associated with reinforcement learning. Okay.
Somebody want to say, can you enter here? Because there's somebody want to say.
Oh, sorry.
Can you enter here?
Yeah. Okay. Okay, so how much time do you have?
We have like 3 minutes. I gotta do the survey and I got to have a few things.
Oh, okay.
So,
We do not have much time left. Okay. So this slide shows how AI, how machine learning works. So there are several steps. The first step is to gathering, to gather information or data, and the second we organize and clean up the data, and then we select a method or a technical. This involves selecting an algorithm such as support working machine, what decision tree. And fourth, the machine starts learning from the data, trying to identify the patterns, relationships, or insights. Once the machine has learned from data, it can start making predictions or decisions. Okay. So this slide shows us deep learning. Deep learning is a subfield of machine learning that is concerned with algorithms inspired by the brain's structure functions known as artificial neural networks. Okay, and this nowadays generative AI is popular. Generative AI models learn the patterns and the structure of their input training data and then generate new data that has similar characteristics. So the difference between generative AI and the other AI algorithms is that generative AI generates new data. Okay. And this diagram shows us the relationship among artificial intelligence, machine learning, deep learning, and generative AI. As we know, machine learning is a subfield of AI. Deep learning is a subfield of machine learning, and generative AI is a subfield of deep learning. This slide shows us the ChatGPT and large language models. ChatGPT is a chat interface to generative predefined, pre-trained transformer machine learning model. Generative model is one that generates believable text or images. Okay. Due to time limit, let's move on to the next slide. Okay. And here are some applications of AI, like predictive analytics, real-time operations management, customer service, risk management, and analytics, customer insight, pricing, and promotion, etc. Okay. Although AI brings us many benefits, there are risks in AI applications. So AI risk can be broadly classified into 3 categories. That is harm to people, harm to an organization, harm to an ecosystem. Okay, so for more details, you can refer to the slides. Due to the time limit, let's move on to the next slide. This slide shows us the AI use case in healthcare. There are different use cases like keeping well, early detection, diagnosis, decision making, etc. Okay. Okay. So should I stop now? Yes. Okay. Sorry, we don't have enough time left. I will show the presentation slides. I prepared over 60 slides. Yeah, we don't have time left. Okay.
Before you go, can we get your email address? Can we get your email address before you go? The email address and your department.
Okay.
We are all from the same department.
Oh, then bring up it. Can you mute your audio?
Oh, sure.
All right, hello everyone. We want to take a quick poll and survey. The main thing is we want to get you guys information so we could looking for send you out the slides and send you out the video. So I just sent out a poll asking for your email address, your department, and some quick questions that we want to know. While you guys are waiting on that right here, while you guys are waiting on that right here, I wanted to show you something really quickly. This right here is a Jupyter notebook. Oh, you guys can't see. Oh man, this right here is a. Huh?
You can show us.
Yeah, I'm sharing. I know, but
Let me stop sharing.
yeah, stop sharing. See that would see if it will show up over there on your screen.
Oh, so
Oh,
you need
mirror,
to-
mirror your screen. Oh,
yeah,
yes, actually, yeah, that will work. There. All right, screen is way too large now. So there we go. So this right here is a Jupyter notebook. As you can see, guys, I am the host, so I got all the cool stuff. Right. And so in the Jupyter notebook right here, what we have right here is a data set. This data set right here is just car data. Of course, your data set will be different based upon what you have right here. And basically, we're going to try and use this data set to predict the price or how much you're going to sell a car for. Right? You're going to try and select how much you're going to sell the car for. And so basically, the basic idea right here is, first of all, we have to analyze and think about the data that we have. So we got to kind of process the columns, look at the data that we have. And then after we do that right here, sometimes we use images and pictures to look at the data, find means and averages and standard deviations, and all that good stuff. Then once we have that right here, what we can do is, this is kind of what we're going to do next time. So I'm kind of giving us a little bit of a bridge, try and whet the appetite. So guys, understand what's going to be happening later on through the technology. Like I was saying, this Jupyter notebook, for example, this software we can run for free. And this software right here is going to do all of the hard work for us. And so basically, we analyze the data, look at how the data this correlates together, how the data splits apart. And then once you have that right here, we build what we call our models. So you can have your machine learning models, or you can have your neural network models. Most of the AI models are neural networks. And what happens is you just take those data right here, and literally it is just running a few lines of code. Like for example, this right here, linear regression, right? Just plug in a few lines of code and that's it. And it goes, if you have like tons and tons of data, it might take hours to do it, but literally it's a few lines of code that takes to get that part done. And then, do I have a neural network on here? Oh no, this one doesn't have a neural network on here, but again, it's the same basic concept right here, is that they've done a lot of those parts already. Literally it's a few lines of code that we need to run, saying, hey, this is our data, and this is what we want to come out of our data. And it will do most of the work for us. Right? So we'll kind of go through something like this in a little more detail next time. Everybody get a chance to work on the poll. Okay, so with that, we'll try and get the recording to you and the slides as well, as soon as we get a chance. Oh, that's fine. We'll take it here. That's fine. Either way, we'll take it here if you don't get a chance to do the poll. Oh, that's fine. All right. With that, any questions? All right. So I'm going to close the poll now.
There's homework, right?
Not really. Just come to the next one.
Oh, this.
You guys have a nice day. See you guys soon.
Yeah, so this is